Okay, so let's talk specifically about folds. So this is one of the two main structures that we want you to identify. So like everything, we're grouping things into kind of big groups, big buckets. There's just everything in between, of course. You can have some faulting and folding that kind of look similar or kind of happen together or transition. For us, we just want to look at these two main categories and have you pick out some of the main types. And for folds, we're going to see that the two main types that we want you to talk about that are formed under compression. So for the majority of folds, once again, there's always some exceptions here, but compression, taking the rocks and putting them under compressive forces, are going to cause them to bend like this. If, of course, some of those previous conditions we've talked about are true. What does that mean? That means that they are a hotter temperature, which usually means that they are formed deeper inside the earth. So they're hotter, they're more ductile, they have the ability to bend. The strain rate is a lot slower, right? Weaker rocks tend to do this. How do we see them in these lovely pictures at the surface? Well, remember, we said uplift and erosion has exposed these, but in general, we would argue that many of these folds that you're looking at have formed deep in the earth and then have been brought to the surface by uplift and erosion. And so when we look at a fold, we want to look at some features, right? So the fold axis is a line that we could draw, or a plane that we could draw, that bisects my fold, where the dip direction has changed. So in this example, we have these rocks that have been bowed upward like this. And so we see that the dip here, right, is away from the center of the structure. And as we come up here, there's a transition in the dip direction from this image, right, to the left. And then over here, it's going to the right. Where's my little pointer? To the right here. Okay. And actually right here, there's no tilt whatsoever right at the very peak, and then it changes direction, of course. So if we look at something, we could try to draw the fold axis, which would split our fold in two, and then on each side we would have a limb, which is this part here that's tilting away from the center in this example. Okay, so we want to identify the fold axis when we can. Now sometimes it's not always easy to do because folds have been overturned a little bit. They don't always look beautiful, and some of the diagrams we show you, we give you some simplistic views of folds. They can be tilted, they can be overturned, they can have lots of different orientations. But we can still decide that if I draw a line up through here, it is separating the two different limbs that I have, kind of like this diagram is doing on the right. Okay, here's the deal. When we're looking at folds, what I'm going to ask you to do in the homework and in some of the quizzes that you're going to take online is I want you to be able to identify between 4 different types of fold structures. A syncline, which you see here, anticline, which we kind of mentioned previous, a basin, and a dome. And so based on some properties that we look at, whether it's a cross-sectional view or a map view or the strike and dip symbols, I want you to be able to use those to tell me which structure you're seeing, okay? And so for a syncline, now this images are a lot nicer than the ones I showed you previous when I was doing the anticline and talking about strikes and dips, but a syncline has this kind of structure, right? This is what it looks like. In cross-section, it should be fairly easy to differentiate from an anticline, which is when the layers are bowed upward like this, okay? So an example would be if I gave you just this side view here, a cross-sectional view, you did not see the top here. You didn't have any of this surface information. And I said, what type of structure is this? This view here would tell you that it is a syncline because it has this shape. So I don't know, in class usually we talk about how to remember some of these things. So it's got that sink shape. It's sunken down. Maybe it looks like a sink or a smile. That sometimes can help you kind of remember the name associated with this type of structure. And so we've got this idea that they're pointed down like this. Okay. They also dip toward the fold axis. Remember, we said we can have a plane that we draw that separates the two limbs. Here it's tilted toward the fold axis, right? It's pointing toward the middle, okay? The other thing that we can use to identify synclines is that the youngest beds are in the center of the fold. So how is that? Remember, the rules when we talked about relative age dating still apply. If these are sedimentary rocks, which when we're doing examples of diagrams and asking you to identify, we're going to assume that all the layers that you're looking at are sedimentary rocks. What that means is they were once horizontal, they have been tilted. And so we're using that information. And some of the information that you already have is that when layers are stacked, when these were flat, this layer, it's the same layer, right, even though we can't see it here, is on the bottom, and this lighter colored layer is on top of this darker layer. This yellow layer is on top of this tan layer. And then this is on top of this, and this little tiny remnant is on top of this tan layer. So what does that mean for ages? The oldest, if we were going to get really specific, of what I see in this cross section is this layer here. It must come down here and connect over here, even though I can't see it. Okay, so this is the oldest. It's on the bottom. Then this one is the next oldest or youngest, but we're going younger as we go upward, right? So then this one, then this happened, then this happened, then this happened, then this happened. This is the youngest layer. So when I look at a syncline, the youngest material, the youngest layers are in the center. And so the two other ways that you'll be asked to identify structures, we said the first way is in a side view. The shape of the layers, how the layers are bent, can tell you what you have. The second way to identify whether you have a syncline or an anticline is the age of the units. If I told you that this layer here was younger and this is older, you should be able to know that this is a syncline because the young rocks are in the center. Okay? And the last way to identify whether you have a syncline or an anticline is the strike and dip symbols. Here you see that the small little line is pointing toward the center. Over here, the small little line is pointing to the center. It's telling you that the beds are tilted toward the center of my structure, right? Toward the axial plane. That is how you could identify that this feature here that's exposed on the surface is a syncline. Alright, so we want to use all three of those. Side view, in cross section, the shape will tell us. In map view, age of the units will tell us, and the dip of the beds will tell us. Right, dipping toward the center, syncline. Young in the center when it comes to age of the rocks, syncline. And in cross section, just the shape. Okay, so I want you to be able to use that information if you're given a diagram to identify that type of structure. Okay, so if we look at anticlines, now we're just looking at the basic opposite of what's happening here, right? So once again, in a side view, if we were just given this side view, the shape of the beds, how they look, can tell you what you have. So it looks like an A or an anthill. That's an anticline. So just in cross-sectional view, you should be able to identify this as an anticline. Of course, there's a couple other ways we can do that. We want to say that the limbs dip away from the fold axis. From the middle of my structure, they're tilted away. And of course, the oldest beds are in the center instead of the youngest. So remember, even though in the surface here, this yellow layer stops It's the same layer over here. It has been eroded away. What does that mean? It has exposed a layer that is beneath this yellow layer. And what do we know about ages of sedimentary rocks? Old on the bottom. So this is the oldest layer. Then this one, then this one, then the yellow, then the tan, then the brown. So of the rocks exposed on the surface, older ones are here. This is younger, younger, and the youngest is on the outside. So this is why we would say that the oldest rocks, if they're exposed in the center, it must be an anticline. We can't see the ones at depth, so those don't count. It's only the rocks that are exposed at the surface, because that's all we can see a lot of times. So, given a diagram, how can you tell you have an anticline? If you are given the cross-sectional view, we would argue that the shape is telling us what you have. If you are only given the map view, let's say you're only given this part of the map, if you knew the age of this unit compared to this lighter one, and we told you that this one in the middle was older, that would be an indication that you have an anticline. And once again, we said the limbs dip away. So here's a symbol, strike and dip. The smaller line right there that has the 30 associated with it is dipping away from my fold axis, the middle. Over here, it's also dipping away. So both dipping away on both sides. So that tells you that you have an anticline. So once again, just like the syncline, you want to be able to identify the structure using all three methods. Cross-sectional view, what it looks like, just the shape of it. Map view, you have two ways. The age of the units and the strike and dip symbols. Okay? So we want to practice that for sure. That's part of your homework. Once again, the lab will kind of reinforce that too. So, just some images of real life ones instead of these. Sometimes they're not as pretty, of course, as what we talk about, but in general, you should be able to look at this. This is a cross-sectional view, right? The shape, at least right here, if I asked you to identify what's happening in the middle here, we'd argue that this is a syncline. It's got that sync shape or that smile shape, and that would be done, right? What is it? It's a syncline. You're done. There are some folds that kind of only got one limb. We don't really talk too much about these. There are some monoclines here in Arizona. If you go up to the Grand Canyon, you can see some. But this is what they would look like in cross-section and map view. But we're not going to focus on these. I just want to mention that they are a structure that we could identify. But for this class, we want to focus on being able to tell the difference between an anticline and a syncline. Okay? And just an image of what a monocline might look like in the real world. Okay. The last two fold structures that we want you to be able to identify are domes and basins. Look, the good news is they are related to the anticline and syncline we just looked at. Okay? And so when we look at a dome, which is what we're looking at here on the left, the difference between a dome and an anticline is the map view. What does it look like on the surface? Okay? The other features are the same. And so, what does that mean? If I asked you to identify a fold, we would look at the side view and the map view. And on the map, we would look at the age of the units and how they tilt. Do they tilt toward the middle or away from the middle? So look, because a dome in cross-section has the same shape as an anticline, that is one way we could try to figure out if we had a dome. The circular pattern that you see would definitely tell you that this must be a dome and not an anticline if I gave you this image, both views, side view, top view. If I only gave you the top view, how would you know if this was a dome or a basin? Well, first remember, the circular pattern tells you it's not a syncline or an anticline. It must be a dome or a basin. And so the other two things hold true for how it looks in cross-section, and that is old rocks are in the middle. So if I have a circular pattern like this, and the oldest rocks are exposed in the middle, it has to be a dome. In addition, the layers are tilted away from the center in all directions. Now in my anticline, they were just tilted away in one direction on either side. Here, they're tilted away this way, over here, down here, in all directions, forming this circular pattern. So strike and dip symbols on here would have the short line always pointing away from the middle of my structure. That's how you would know that you had a dome. And look, they don't always look perfectly bullseye. That's just to illustrate the purpose. But this is an example of a dome where I have this same unit that wraps around here. The older rocks are exposed in the middle. Without having any other information, I would identify this as a dome. It is a circular pattern and it has the oldest rocks in the middle. If there were strike and dip symbols on some of these layers, there would be a long line like this with a short line pointing away, pointing away, pointing away, pointing away. No matter where I look, the short little line of my strike and dip symbol would always point away from the middle. And so I could use those two features to identify this as a dome. The last thing I want to mention about these type of structures is, remember, when we use the term dome here, we're talking about a structural, geologic dome, not a topographic dome. What does that mean? That means if you were hiking along, this might be perfectly flat. Okay, there would be no domed up layers like you're walking up, the Superdome or something. That's a topographic dome, right? Where you walk up a hill or something like that. That is not always true for a geologic dome. What we're looking at is the rock layers to tell us that. This structure here, as it's illustrated in this diagram, is pretty flat walking across here. You would not go up or down in elevation very much. You'd have to look at a side view or age of the units or measure the strike and dip of the units to determine you had a structural dome. Okay? So this is the information and the features we're going to use to identify a dome and a basin. Once again, same circular pattern. So what we want to be able to do from a map view, looking down on the surface of the earth, if you saw a bullseye pattern, right, a circular pattern, your first thought should be, it's a dome or a basin. How do I know which one? Well, you either need age of the rocks or the strike and dip of the rocks. So remember, given the circular pattern for a basin, instead of old rocks in the middle, it's got the youngest rocks in the middle, because in cross-section, the beds are bowed downward like this, which means young on top, young in the middle. Okay? Or if we were to draw strike and dip symbols, the small little line would point toward the middle of my feature. And so strike and dip symbols would tell you you have a basin, or the age of the rocks would tell you you have a basin. In cross-section, right, it bows downward like this. Now look, I get it. If all you got was this cross-section and had no other information, you wouldn't really be able to know if it's a basin or a syncline. So you would need additional information to figure that out. Okay? And once again, a realistic view, okay, yeah, dartboard bullseye, that's not what they all look like. It's a little messy, but based on age here, we know that this is young, this is old, and the young stuff's in the middle. This is a basin based on the age of the units here. So in map view, age might be all I need. I see there's a circular pattern, young in the middle, must be a basin. I see a circular pattern, and all the strike and dip symbols have the little dip indicator pointing toward the middle. That would also tell me I have a basin. Okay, so when we give you some diagrams, we'll tell you which view it is. Is it a cross-sectional view or is it a map view? based on that information, you want to evaluate the structure. You want to use either the shape, you want to either use the map pattern, circular, or if you remember, and I didn't really emphasize this when we looked at the synclines and anticlines, that looked more like a striped pattern. So you can kind of go back to that slide and kind of look at that, and it had more of a striped pattern. That's an indication of a syncline or anticline. Circular pattern, indication of a dome or a basin. And then in order to pick out which you have, you need age of the rocks to tell you what you have, or the strike and dip of the rocks to tell you what you have. So you want to use either of those to figure out the different types of fold structures you have, and then piece of cake. So that's how you're going to work through identifying the different types of folds. And then next we'll talk about faults. So we'll take a little break and get back to that in just a second.